Hey guys, and it's Flight Sim Today here. I just want to say thank you for watching this video. The content you're about to watch was taken originally from Airline to Sim, who are no longer training. You cannot even get this program anymore. It's gone. Originally £40, it was an in-depth and really good resource for the A320, which is still relevant today if you're using the Phoenix program. Originally hosted by Ben, and they had a guy called James who was a real airline A320 pilot. I will be taking the 27 episodes where possible, snipping them up into much smaller chunks, making it easier for you to digest, and maybe you don't want to learn one thing but learn another. So if that's your thing, please do subscribe so that you can keep up to date with all the new videos that will be coming out over the coming weeks and related to this.
Now, there's a bit more to understand. The fuel pumps, I guess, are relatively straightforward.
Yeah.
How many tanks do we have on an A320?
So we've got an outer tank, an inner tank, and a central tank. So we've got one outer on each side, and then two inners, so one on each side again, and one center tank.
Okay. All right. And we have pumps. What does it do? Do they pump the fuel out of the tank into the engine, or down the pipe connected to the engine?
That's what they do. They kind of pump it down the pipe into the engine. You know, the pump itself is in the tank. It's submerged in the fuel, and it sucks it in and then sends it to the engine. That's
okay. And can we? Obviously, we're going to turn these on. If we turn them off during the flight, does the fuel stop and the engine stop?
So with the tanks that are on the sides, so the inner tanks and the outer tanks, they will still supply fuel because they're above the engine. So they sort of, by natural gravity.
So just gravity will fall down into the engine.
Exactly. But the center tank, because it's below the engine, you can't use the fuel in that anymore. Okay.
All right. So it would be, I mean, not that we're going to do it, but it would be a bad idea to start turning these off. Could we start the engines without them?
I don't know, actually. You might be able to. You might be able to, but it might need a sort of spike of pressure that we might not be able to give it from just gravity feeding.
Okay.
But it's possible.
So it's possible, but it's really not recommended.
No, I think
presumably as soon as you rotate and the fuel potentially sloshes back a bit,
you might get a phone call from Eurojet saying, "What were you doing?
What were you doing?
Why?
All right. So we know the what. Let's talk about the how.
So normally for the procedure is we turn the pumps on, apart from the center tank pumps if we're refueling.
Okay.
So that's it. And we just leave them like that.
So do we have to remember then to turn the middle ones on and off during the refueling? Is there an easy way of doing it?
Yeah, really the easy way to do it is to just engine shutdown, always turn the center ones off. Because if you do refuel, then you needed to have done it. If you don't refuel, it doesn't really affect it anyway. Because
I guess it's quite hard to know exactly when they're refueling, because the airplane will tell you when it's refueling.
Yeah.
But it's quite hard to know when he's fueling, when he's not, when he's finished.
Yeah, that's why it's the easiest just to do it that way.
All right.
Just keep it safe, keep it simple.
So the left side go during the setup, first flight of the day, we turn them on.
Yep.
And they stay on the whole day.
Yep.
Until we're finished.
Exactly.
And then the right side is the same. The center pump on and off with the engine.
That's correct.
And that's it.
Yeah.
All right. Sounds pretty straightforward.
Yeah.
There's a crossfeed in the middle. Is that a bad day switch?
Yes. Well, not necessarily. I mean, it normally comes from a situation that's made it happen, but you can get imbalances of fuel for other reasons.
So the APU, for example, can imbalance the fuel, right?
Yeah, that's right.
So the APU, where does the APU get its fuel from?
So the APU gets it from the left side, and we can actually see it on this diagram here. You can see the little arrow is on the left side of the system.
Yeah,
so it gets it from there, and it has its own pump, so we don't need to turn any of these pumps on for it to work.
Right. So at the moment, it's getting it all from the left side.
Yep.
So none of the fuel for the APU is coming from the right. So if we sat on the ground for 3 hours, then we would have a huge imbalance.
Exactly. Yeah. So that's when we would need to use it. So not necessarily a bad day, but
something unusual.
Yeah, something.
So we're going to try and get a situation. We're going to try and show you when you would need to use that.
Yeah.
And then the mode selector in the middle.
So what that is the Airbus has sort of fuel pump logic for the center tank pumps. So it's when the slats are out, they use the fuel from the center tank, and then it doesn't use it for takeoff. And there's various logic things.
There's
for that.
Lots of weird things.
Logic, and that's why that mode selector, if you see it says auto next to it, so when it's in its position, it is now, it automatically takes care of that. And if you, for whatever reason, want to turn that off, you select it off, and it then doesn't do it. It does it manually.
Gotcha. All right. Now, going above that, this is the hydraulic system. Now, I guess out of all the systems, probably apart from stuff like the flight control systems that are really quite complicated. The hydraulic system is quite a big deal in the Airbus, right?
Yeah, it is.
So hydraulic systems, we've got 3 of them. It's too big for us to manually move the controls, right?
Yeah, that's right. Like, this is why these large aircraft, and it was around the 50s and 60s that sort of hydraulic boosted controls came in, where they had hydraulics before, but they needed so much effort to move them. This is why we have powered flight controls now, where we move something, a yoke or a side stick or whatever, and then we use the hydraulic system with pumps and actuators to move the flight controls for us, so we can have a reasonable amount of force and still fly big aeroplanes.
So something like, so for example, take the landing gear.
Yeah.
When we put the gear up, the gear obviously has to fight gravity and withdraw up into the wheel. Well, I can't imagine how heavy the landing gear is. I bet it's very heavy.
I think it's 3 tons each.
3 tons each?
Yeah, something like that.
So the whole aeroplane, total weight is what? Like max takeoff weight?
It's like 77 tons.
77 tons, and 6 and a bit less, I guess, with the landing gear.
Yeah. So
say 3, 6, I don't know, let's say 1.5 tons. So nearly 10 tons is just the landing gear.
Yeah.
Wow.
Yeah, it's a lot, and the gear, you can see it when we were doing the walk around. It's a huge piece of metal.
Yeah. And this is an A320, so think about a 747 or A380 landing gear.
Yeah.
Like,
it's a lot.
Like, that weighs as much as an A320.
Yeah, more than likely.
Yeah.
Yeah, and they're a huge piece of equipment.
So there's no way, like, you could have an electric motor or something to bring it up, but you need a lot of power to get that up.
You need a lot of energy to move it, and the only way to sort of transfer that sort of power now is hydraulics.
Okay.
If we use an electric motor, I'm sure we could do it with electrics.
But it would need to be a huge motor,
Huge
very
motor,
heavy.
Yeah, and not practical.
Yeah. Okay. All right. So we use hydraulics. That's what we use it for, amongst other things. And do these all power different systems?
Yeah, so each one, they've got it set up so you can see it now on the diagram. So the green system has 1 engine pump, the blue system has 1 electrical pump, the yellow system has 1 engine pump and 1 electrical pump.
Okay.
And that's what we can see with these diagrams.
So we can see from left to right then, the engine 1 pump drives the green system.
That's correct.
And the green system will drive various things.
It's the primary system.
The primary system.
Yeah.
Right, okay. And then the blue system has that electric pump that you talked about. The yellow system has its own engine 2 pump and an electric pump. Now, if everything's working, does the aeroplane look after itself with this? It will just provide the hydraulic pressure to wherever it needs to go.
Yeah, there's no need to turn the pumps on manually before pushback or anything like that. It will do its thing.
Okay.
It will sort it out, and it will do everything it needs to do.
Okay.
Yeah.
Now, we're going to come back and investigate the hydraulics in a bit more detail. But for this point in the training, is there anything on here that we need to press and anything that we need to know about?
Realistically, we can just leave the panel as it is now, just to be aware there's 3 systems, and it's good to know that the green system is the primary system, so it does the landing gear, a lot of the flight controls. The blue system also does quite a lot of the flight controls, and the yellow system is the one that's responsible for like the parking brake and alternate braking system. However, with the yellow system, there are, as you can see, there's an engine-driven pump and an electrical-driven pump.
Okay.
Now, it might not really seem like, well, why does it need an electrical pump? There is a reason why it needs an electrical pump. When we come to look in the flight preparation, we look at our little brake indicator, and it has they call it the triple indicator. That's what it's actually called.
All right, so let me just slide down here, and we'll have a look at this. Now, this is this little indication here to the right of the landing gear, yeah?
Yeah, that's it. And they call this the triple indicator because it has 3 needles. And what we can see here is when the parking brake is set, the parking brake, as we said earlier, is run off the yellow system. So this is displaying pressure from the yellow system. It's showing that the parking brake is on. It's got 1,000 and a bit PSI on the right and the left brake. And the accumulator pressure, that's what acupressure is at the top, is a bit low.
Okay.
Yeah.
Now, what's the accumulator? Is the accumulator, by its name, something that keeps and holds hydraulic pressure from? Is it the engines when they're running?
It's basically, the accumulator is a big sphere somewhere in the bay of the aircraft, and it stores pressure in it. And it will get that pressure.
It's almost like a big balloon.
It's like a big balloon, yeah. It's like a big pressure balloon that's for the yellow system, and it's there, ready to be used when it needs to be. Because at the moment, we have no hydraulic systems.
Okay.
They're all
So the APU's
off.
running, but the APU doesn't do anything for the hydraulics?
Nope, it just does air conditioning. So it does bleed air, electrics, and that's it.
And that's it, right?
Yeah.
Okay. So what makes the big balloon, the accumulator?
Yeah.
That presumably, when the engines are running, it gets restored. It pumps it back up.
Yeah.
But then when we park the aeroplane, does that like a balloon? Does it deflate over time?
Yeah, it will lose that pressure over time just
Okay.
because it's sitting there. It's not inherently a perfect seal, so a bit of it's going to leak out, and we're going to use the parking brake now and again,
Okay.
and it's going to use the pressure that's inside the system.
So if we turn the parking brake on and off, we'll see that drop.
Yes.
Yeah?
Yeah.
Okay, so listen, just to kind of prove this, I mean, I'm guessing you wouldn't really do this on a real aeroplane, so I'm going to turn the brake. It doesn't matter, the chocks are in, right? So
yeah,
we're
you
not
could do
going to
it.
roll
You
away.
could do it, you know. Yeah.
So I'm going to apply the brakes once. There's one brake application. So you see it comes back up, and then you can see it's slow, but it is perceptible. As I turn the parking brake on and off, you can actually see it. It is dropping, isn't it, bit by bit?
It is, and you can see it. And the accumulator, when it's fully charged, is good for, they say, 11 brake applications. That's
Okay,
what
so
they say.
that's
roughly.
That's brake applications, as in you braking the airplane to a halt. That's not turning the parking brake on.
No, I imagine when they say 11, they're being pretty conservative anyway. That's like sort of like the best day, and it's for landing. Yeah.
Right. Okay.
So you can see we've dropped quite a bit already.
Yeah. You can see it's coming down. So once you've turned the parking brake, I mean, I know you're not going to sit at the gate and turn the parking brake on and off like 15 times. You'd be a bit of an idiot to do that.
But for maintenance, they could have been moving it around all night, and you can actually see, look how slowly the pressure. See, before we were at 1,000 and a bit psi on each wheel, and now look, it can't maintain 800.
Yeah, that's right. Right, so just applied the brakes, and now we've got a bing, and it says brakes, brake Y, accu low pressure.
Yeah.
So does that basically mean that the sphere has now lost so much of its pressure, it's now struggling to actually keep the parking brake on?
Yeah, you can see that the brakes are only able to do about 500 psi now, when before they were over 1,000, so they've almost lost half of their braking pressure.
Okay.
And the more that we do it, the worse it's going to get. So I imagine this warning is set up for a point where it's now getting pretty dubious if it's going to be able to hold it on the brakes.
So if they take the chocks out, there is a danger it might roll away.
Yeah, there
if
is.
It's a steep slope.
Yeah.
Right, okay. Now, how do we fix this?
Well, there's two ways to fix it, and I'll add as well a little bit of a note that you can see the little green that's on the accumulator pressure. Anytime it's outside of that, we can do this procedure that we're about to say. We don't have to wait for the ECAM.
We don't have to wait for the ECAM.
No, but this is the ultimate result of it getting really low is this.
Yeah.
But we can do it at any point. If you get in the flight deck a bit low, then we can apply what we're just about to say now. So yeah, we can use the yellow electrical pump. Now the yellow electrical pump will automatically put pressure into the yellow system, which is then going to charge up the accumulator. Job done. But to do this, there is a little bit of back and forth you need to do. Because you're going to pressurize the hydraulic system, you need to ask the ground crew, make sure they're clear.
We're pressurizing systems on the aeroplane, and it is potentially dangerous. And,
it is.
Yeah.
So that's why you have to ask and check, and it can create a delay, at the start of the day, which realistically maybe is not what you want. So there is another way, a trick.
There is another way.
There is another way,
and
it's a good way.
Trick?
It's a good one.
All right.
And it's what I use.
Okay.
So,
all right. So do tell.
So what it is we were saying earlier on that the cargo doors open and close.
Yeah.
With a hydraulic power. Now they are used off the yellow system, so they all come off the yellow system. So when you might have heard it as a passenger, you're walking up and you can hear the doors opening and closing. They select the door, select to open, and it automatically turns on the yellow electrical pump.
Really?
Yeah. So it uses the same pump.
The cargo door.
Yep.
Knows that this is low, and it will recharge. Hang on. Does it use it anyway?
It uses it anyway. It's just an after sort of effect of it doing it.
Right,
yeah.
okay.
Yeah.
So basically, any time the cargo door gets opened,
yeah,
it will recharge the acupressure, this little sphere.
Exactly. Because just by design, they're using the pump, which to open the door, which is fair enough.
Which depletes the acupressure.
Yeah, which basically, because they're using the electrical pump to open the door, it then goes, well, the pump needs to come on because I need to open this door, and it will, by design, because it's pressurized the hydraulic system, just as an after thing, pressurize the accumulator.
Okay,
yeah.
So basically, if they kept opening and closing the doors, that would then deplete our ability to keep the brakes on.
Yeah,
which is not good.
No, so that's why it always just turns on the yellow electrical pump. It doesn't wait till it's low, even if it's fully charged. The accumulator can't have any more charge in it. It will still run the pump. Always run the pump. Yeah.
All right. So if I open up the, are we calling this FMS MCDU?
MCDU. Yeah.
Okay.
Yeah.
How do I actually turn it on? Is it hold down the
that,
brightness button, right?
That's it.
And you get this little ready thing.
Yeah, it's like the
yellow
thing running through its own little test.
Is that a little self-test? Is that what's going on here?
Yeah, that's what it's doing.
All right. Okay. Now, I go to options. This is not something you have in the real aeroplane, obviously. No, not options. If I go to doors, and then is it just the forward and aft? It's not the bulk.
The bulk doesn't have an electrical operation.
Is it just you open it manually?
Yeah.
And that's
then that's why that wouldn't pressurize the hydraulic system.
But the forward and the aft.
Yeah.
They do.
Any of those because they use a hydraulic.
Okay. All right. So I'm going to open the forward. I'm going to move that out of the way.
Yeah.
And you're saying that this is going to now repressurize
It should.
the brake pressure.
Yeah, it should. It will.
If they've modelled it.
If they model it,
If
it
they've
will
modelled
work.
it. Right.
I have faith.
FS Labs, we're counting on you. Let's do this. Wow.
There we go.
Look at that.
And you can hear the pump.
Yeah.
That noise is the yellow electrical pump.
Yeah.
And if we basically put the pump on, it makes that same noise. That's
Yeah.
not the doors, that's the pump.
So, yeah, I always thought whenever I flew this aeroplane before you came along, I thought that was the sound of the doors opening.
Yeah.
And it's not. It's the pump.
It's the pump. The doors are the pumps are being powered by the door. The doors are being powered by the pump.
Right.
But the pump sounds the same if you use it or not.
if I open the aft one, you can see it comes up. The ECAM says cargo. Even though it's full,
it
still runs the pump.
Still runs it because it doesn't want to use the accumulator pressure. The accumulator pressure is for the brakes only.
Right.
Really.
Okay.
Yeah.
That makes sense.
Yeah.
Wow. So that's good. That's an impressive bit of modelling, huh?
Yeah. It's very, very impressive that they modelled that.
Yeah. Okay. All right. So what I'm going to do is, just because I don't want to kind of jump the gun, I'm going to turn that off again. And we're kind of back where we started now, except we've got the cargo doors open, which is all right.
No bad
it's not
thing.
really a problem.
Yeah,
we can close them again later on.
Yeah.